Guys, we will be continuing our lecture on moments, and we will see how moments are actually very useful in the real world situations. So let's talk about one of the very common examples, which is a seesaw. Let's say I have a seesaw here, and it measures around 5 meters in length. Right, so let me draw a seesaw here. This is the seesaw. And the length of this entire seesaw is, let's say, 5 meters. And I am dividing it in sections. This is the first meter, let's say this is the second meter, the third meter, the fourth meter, and the fifth meter. So this is the first one, second, the third, the fourth, and the fifth. Alright, so this is the situation here. So this does not look really proper because I haven't calibrated this properly, but let's just assume it is this way. Alright, so let's say I have my fixed point at this measurement mark at 3 meters from the origin point. So I have my fixed point at 3 meters at this mark, because we know that we can make any point as our pivot, because it's just an arbitrary point. It can be any point, and we will see in the next lectures how that would not affect anything. So let's say this is the pivot, and one of my friends decides to sit here at this mark, and let's say he's a heavy guy and he weighs around, let's say his weight is around 200 newtons, just a random number, 200 newtons. So we know that when he sits on this seesaw, he would be exerting a force, gravitational force, which would be equal to his weight, and this force at this point of this friend is 200 newtons. Alright, that's great. So let's see, now we know as soon as he sits at this point, you should have the intuition that the seesaw will move like this, in this direction. Why would it move? First of all, that is because he is exerting a torque or a moment. Let's find out what happened. What is the moment that he exerts on the seesaw when he sits at this point, at this 5 mark. Here, this is the 5 mark here. He sits at this point. So we know our formula: moment is equals to force times displacement or distance perpendicular distance from the pivot, which is this distance. Always remember that this distance will always be perpendicular to the applied force for the moment. Whenever there is a perpendicular distance from the pivot, from the fixed point, there is always a moment. So let's find out the moment. Would be the force is 200 newtons times the displacement, which is 2 meters in this case. This is 1 meter and this is 2 meters. So the moment would be 400 newtons meter. That's it, that's great. So he is exerting a moment of 400 newtons meter in this direction, which is the clockwise direction, because the clock moves in this direction. So this is the clockwise direction. Now, what if I decide to balance him, or to do something that he is not able to move the seesaw? What would I have to do in that situation? So let's see. In that situation, I mean, if I'm just saying it, it's a very normal thing. But physically speaking, what I am trying to do is I am trying to balance the moments. and by balancing the moments, I am bringing the entire seesaw into an equilibrium situation or a balanced situation. So, since my friend is applying or exerting a moment of 400 newtons meter clockwise, I would have to make sure that I am exerting a 400 newton meter moment in the anti-clockwise direction. Only in that case, the moments would be balanced, because as the principle says, sum of moments clockwise should be equal to sum of moments anti-clockwise. So that's it. So what I have to do, I have to make sure that I produce a moment of 400 newtons meter. Let's see if I weigh around, this is me, let's see if I weigh around 150 newtons. That would mean that I would be exerting a gravitational force of 150 newtons. So now the question is, where would I need to sit if I have to produce a moment equals to the 400 newtons meter, but in the opposite direction? So that is an easy question. Let me just clear things up here. Just remember that this is the 400 newtons meter that he's producing. Alright, so this is the question here. Now I am producing a force of 150 newtons. Alright, and I have to make sure that I produce a moment of 400 newtons meter, but in the anti-clockwise direction. So as our formula says, the moment is equals to force times perpendicular distance. I know the force, but I don't know the distance where I'm going to be sitting on the seesaw to make sure that the seesaw is balanced. Let's see. I know the distance, this is 150, but I don't know this distance here. So let me just assume that this distance is x. And when I multiply these two things, I would be getting an answer of 400 meters, 400 newton meter. So let's just find out x is equals to 400 divided by 150. Just take it here, and if you just solve it, you would find out that it would be something around 3 point something. So let's assume it's 3.125 meters. So what I will have to do, this would be around 2.75 meters. If you just calculate it, I don't have a calculator right now, but if you just calculate it, this would be around 2.75 meters. So if I have to balance his moment, or to bring this seesaw to equilibrium, to a stable position, I will have to sit on the left hand side of the pivot at a distance from the pivot of about 2.75 meters, which is this is 1, this is 2, and somewhere around here at this let's say this has to be 2.75. And when I sit here, I would be exerting a moment of 400 newton meter in the anti-clockwise direction, and this guy would be exerting a moment of 400 newton meter in the clockwise direction. And since the sum of the moments clockwise in the clockwise direction would be equal to the sum of the moments in the anti-clockwise direction, it would bring it to equilibrium, or the seesaw would not be turning. So we'll do some more seesaw problems, because there can be a lot of them. So we'll see how we tackle each of these problems in the next videos. So stay tuned to it. Thanks for watching.